Hey Rovers, in the last video you saw me put the sides on, and that was a huge step forward because it allows me to control the temperature. Right now in the workshop we have -6 degrees Celsius, but I can control that temperature and get it up to 20 degrees with very little effort inside the boat. So we're going to put all 5 of the remaining ring frames in this video. The Wave Rover 650, a design based on my single-handed ocean voyages. She's small, light, but easy to build and strong enough to cross any ocean. My name's Alan Mulholland, and this is the Wave Rover story. So I'm inside Wave Rover right now, and it's kind of cozy on account of the tarp that I have covering it in. So really what's left on the structure are 5 ring frames, and I'm going to show you where they're going right away, and the longitudinal stringers that will go along, over top of the beams, and that'll give us the structure necessary to actually put the cabin top on. There's a bit of a twist to all this, and I'll explain that in a moment. Right now I just want to show you where the frames are going. So the bulkheads are in. We have one right here, another one here, another one here, and another one here. Of course, there are more forward and aft of what I've just shown you. Now the 5 ring frames are right here. So this is one right here. The black dotted lines show all the ring frames. And there's 5 that we have to put in. And there's 2 more up here. This is the 4th coming up here. And then the 5th one over here. Now these 2 in the forward of the watertight bulkhead, they're going to be pretty thick, just like this one. And that's on account of they don't really have any other structure to help load them. But these ones right here, you can see it comes down like this, and then the load is stopped right here. But it's not really, it's being transferred here, and it's being transferred to this piece of plywood right here, which runs all the way to the back and all the way to the cabin, to the bottom of the boat. And then I haven't put it in yet, but there's a line right here, and there will be another section of plywood that'll connect the ring frame into an entire ring. And that's why we call it a ring frame. It's all connected, and any load that should hit the boat on the sides or anywhere really is being transferred just like an egg, if you will, transfers a load. In fact, it makes me think of when I was sailing across the Pacific. I would come across all these Japanese glass fishing floats, and they came in all different sizes, but they had floated all the way from Japan all the way across the Pacific to the Pacific Northwest near Canada. Totally survived. And why did they survive? You know, being glass, you would think they're so fragile. They survived because they were round and they transferred the loads so well. And that is how the ring frames work. And that's what gives this boat the strength it does. And yet it's so light. It's just 3/8, that is 9mm plywood. All right, I said there's going to be a twist. We're going to step outside to see what the twist is. So the twist is, I'm going to power the whole shop. Well, that is the tools, just with the Bluetti power station. So that is like the table saw and the worm drive and the worm drive skill saw that you see just to the left here, and also the router. Now those are all pretty heavy duty tools in the form of the amount of amperage they draw. They're all 15 amps, well at least the worm drive and the table saw are. I'll be using some lighter tools as well, the jigsaw and the palm sander, but altogether I want to see if the power station can give me enough power to do all 5 of the ring frames. I suspect it will, but it'll be interesting to prove that point to myself, because there's room on the boat to take this, I know that I said that a few videos ago, and there were some people who were skeptical about what if a single component goes inside this between the inverter or the charge controller and the battery. Well, yeah, that's a concern. That's a concern with just a single system as well, that you could lose one component. But my plan right now is I plan to have a regular system with two 100 amp hour lithium iron phosphate batteries, a charge controller, and a power panel. But I'll have a switch in there where I'll be able to isolate that entire circuit so that the solar panels no longer go to that circuit I just described, and instead there will be a second line where I'll be able to charge this. So in a sense, I'm going to have two independent electrical systems. Now, I don't really need a lot of inverted power. I don't need a lot of AC power. The only thing I can think of really is to have some charged batteries for a drill. That's the one item that I sort of want to have in an emergency. I want to be able to quickly drive screws or drill holes to, if there's a hole in the side of the boat, grab a piece of plywood, get it on there, put some screws in, stop the leak just as quickly as possible. That's what I'm thinking. So that's the advantage of a cordless drill / driver. So I'll be taking those with me. As far as the other tools like saws and things go, I don't plan to take a lot. My hand tools are fine in that respect. I mean, I'll see what I have. I don't have a lot of cordless tools to start with. And I know they're handy, and they're a lot better now than they were 30 years ago when I started carpentry. So I'll be relying on this more for a backup system. Now, when it's fully charged and it's letting electricity out through the DC, it's as efficient as my other system will be. But whenever you take power, DC power from the battery, run it through the inverter, and plug in an AC tool, you do get loss. I think it's somewhere in the order of about 20% loss of your power to turn it into that AC. But for low amperage draws, say in port, I want to edit some videos, I can always plug into this inverter, and that's a small draw really. 100 amps an hour I think is what 100 watts an hour I think is what a laptop consumes. So I'll be using this entirely. Let me just show you how I went about charging it, because it's really dead simple, and I also want to show you how we go about charging it with the solar panels. Well, charging from the main circuits that I have in the house, it's pretty straightforward. It comes with this charger. You plug one end into the wall, you turn the machine on, I'll show you that in a second, and then you just open up this little case here and plug it into the wall, and it starts charging. It takes about 4.5 to 5 hours to charge this fully if it's been depleted, and then it's fully charged with 2048 watts. Now, if I was on the boat, of course I can't plug into the wall, so this thing won't really be of much use. So what can I do? Well, it comes with three different, another way of doing it, and that is with this particular circuit, I open up this, and this is pretty cool because it can only go in one way, and it has little locks on it to prevent you from getting it wrong. That any vibration that happens in the boat is not going to allow that to come out. That's nice and solid. And then this end, with these two pins, gets plugged into this end, female end. Oh, and it has plus and minus on it, and you line that up with this, plus and minus, positive and negative. And now it's plugged in, and you probably, if you own a boat and have solar panels, you probably recognize these. These are the standard adapters for solar panels, and I just have to take the red and the black, line them up with the red and black that are coming in from the solar panels. When I do that, I do not need a charge controller. This connects directly to the solar panels. So I'll have 300 watts of solar panels on the boat, and I'll be able to plug that in. Now, this can take up to 900 watts. Of course, I'm just a little boat, so 300 watts. I'll be able to keep this topped up and my other system topped up at sea, with the advantage that I have this emergency system. All right, the unit is on. So you turn it on by pressing this button, and when it lights up green like that, it's on. Now you can't tell it's on right now, but if you touch the screen, then you get to see the display. There's 100% power in it, and there's nothing coming in and there's nothing going out, but it has DC. If I want DC, I press this and then I turn it on. And now I can use all the DC ports, and that's really efficient. Now I've turned the DC off. I'm turning the AC on. I mean, this is really intuitive. You don't need a manual to figure this out. Now the AC is on. It's sending power from my battery through the inverter to the AC load. And that's what these two power cords, and the power cord's going to the worm drive, and we're just going to give that a test right away to make sure that that will start under this load. And by the way, I've had generators before that couldn't start a saw like this on the construction site, because these draw a fair amount of power, just like the table saw. Anyway, we'll see what's going to happen right away. Okay, so the unit is now on. This is my very first time using it, and let's see what happens. No problem. Now we're going to be testing this under load, of course, and we'll be doing that right away, and we'll just keep track of how much power. See, I want to be able to do all of those 5 ring frames without charging this, and we'll see if it can keep up. Anyway, time to crack on. Now, as far as tools go, these tools that you see right here, these 4 tools, these are the tools that I use 90% of the time. And if I had no other options, you know, I have a table saw and some other tools, I could probably build the boat just with these tools. Now, having said that, that's what the power station is operating for me for the building of all the ring frames. So I'm making one of the ring frames here, and you've seen me make these templates a lot. This is the template right here, and they're easy to make. I've done several videos on them now, and I'll put a link to those videos in the top right hand corner. Now, what I want to accomplish is, this is a ring frame, and I want all of them to have the same depth from here. I want it to be 4 inches from what would be the hull edge to the inside, because this is against where the bunk is, and I want to make sure I can put some extra material for a shelf that lines up over all the ring frames. So I've already measured this, and I know I've got 4 inches from here to here. So, but that's the easy bit. The more complicated bit is making this fit the hull right along here, and making this notch fit our sort of complex stringers now, and then coming all the way up. And I know, and I'll show you how I know, that the top of the ring frame ends right here. And I've annotated this because I've reused this over and over again. On the other side, you'll see 3A. So I have it laid out now, and I want to make sure that this is 4 inches deep. So an easy way of doing that is just to grab something that's square, line it up on your line. There we go, good. And then just make a couple of index lines here. And take your tape measure then, and just measure out 4 inches. Okay, so now that I have those, can just grab a straight edge, line those two lines up. There we go. And then just connect those. Now the second thing I want to accomplish is I want to make sure that this 4-inch section comes up 16 inches. Now I just need to extend this bottom line here. So 16 inches from there is to this point. And then I know up here is the top, just where the beam section of the ring frame is. I'm just going to extend that. And now what I want to do is just connect this 16-inch point with the top up there, and that'll give me, I'll show you in a second, that'll give me all this extra width here where it's really needed. Now in the plan it only calls for 3 inches, but I've extended this to 4 inches because I just want that extra protection, although 3 inches from an engineering perspective would be enough. And when you see all these ring frames in, I think you'll get the picture, but I need that 4 inches for depth for the shelf, and at the same time I have to, because of the bend in the hull, I have to use a wide piece of ply, and rather than just cut it off and stick rigidly to the 3 inches, this would add up to probably not even a quarter of a pound of plywood, so it's not a big deal. All right, so now we'll cut this. So whenever I go to make these cuts, I like to hold this firmly. So I use a clamp, and then I'll just, because it's a straight line, I'll just use the skill saw. So with most of the straight cuts done now, I'm switching over to the jigsaw to do the cuts that have a bit of curvature or difficult to get to. So that's the advantage. The disadvantage of the jigsaw is it's nowhere near as accurate as the skill saw for making straight lines. All right, that's pretty good. Now I have another tight cut to make over here for the notch. Now to get these final 2 cuts, it's better to come at them from a different angle than to try to round off, because that's close to a 90-degree angle. So. Alright, so at this point I want to round these 2 edges so it fits neatly. So I switch over to the palm sander. And then finally, I just want to clean up this edge right here because we'll be running a sheet of ply across it, so I want it straight without any problems. I tend to either cut on the line or cut on the waist side of the line. I can see I've got a little bit of space here, and I also want to improve this, this arc. So I'll use the belt sander. So now this is ready for a test fit, but while I have the camera set up, there's always one extra step I take, And that is, I like to take this edge and just round it a bit, because this is the edge that's against the hull, and we're putting a fillet in there, and it just helps the fillet really penetrate. So I just use the palm sander again. All right, now it's time for a test fit. So these are the ring frames I currently have under construction. It's beginning to look pretty cool, I'd say. And this is the one that I'm just working on right now. Let me see if I can get a little more light over here. And as you can see, it's fitting pretty nicely. Don't forget, it's getting a big solid fillet. Now, that's a little bit wider than I normally would do, but it's cut at this point. I probably should have done the test fit before making that cut. That's what I did with the others. But that's fine, because it gets two big solid gussets just like this, either side of it, and that whole gap will be filled with epoxy. So if anything, it'll end up being probably stronger than if it didn't have that gap. This is an unfinished segment as well. This, after it's installed, will get trimmed back quite a bit, you know, up to about a 4-inch depth right across the top. Okay, so when I make a cut like this, I generally do it from both sides. And the reason for that is because when you're cutting this, you can see that the saw will rip the grain on the upward side of this pattern, and yet where we want it, our actual beam here, it's nice and clean. We're not getting any of the tear out. And so if I carried on and went past this curve heading this direction, I'd start getting, I'd start getting tear out on my line here. So that's the reason I've changed direction and started using the saw from the other side, and then I'll come back and just connect in the center. Just a little tip to help you avoid tear out. So it's -5 outside, but it's almost 10 degrees Celsius in here right now. And we're working on what is the last ring frame. And I'm trying to capture it here. The space is a little bit tight, so it's hard to film this. So I like to do this in a few different pieces. So I have this top piece right here, which is oversized, but it's being supported by these verticals. And then there's a third piece that I'll be putting down, well, third, I guess it's fourth piece that I'll be putting down that will connect right across the bottom, just like we're seeing in these other ring frames. And the trick is to try to support everything until you can make this a little more stable. So I just have just a 1x4 going across the top, and then I've clamped the actual horizontal piece of the ring frame to it. And right now I've got the space heated up, and Mrs. Rover's mixing up some thin epoxy because I have to wet out all the surfaces that I'll be gluing. So I've been doing this in different phases just to make things easier. So I've got, as you can see, I've wetted this out and I've put glue on it. And that's because the next piece that'll be going on will be that one. But I've also prepped the area up here, and that's getting ready for the gussets that's going on the forward side of this frame. And I already have the gusset on the aft side. And the reason I have to do it in a sequence like that, there's just a couple of screws in that one, and it's holding everything together so I can undo this beam support that I had on there in the previous little segment. All right, I have to shut the camera down to get the next job done. So now that I've got all the gussets installed, well, not all of them, but most of them installed, and down on the cross section here, I can do the final bit of wet out, which is wetting out this area and this area right here. And then, of course, I'll wet out all the areas that will get a fillet. Yeah, it's multiple steps, but you're able to keep your hands clean, and you're able to control the temperatures, you know, how long the working time is with the epoxy by doing it this way. Well, it's a little hard to capture, but all the frames are in. Let's go inside and take a closer look. Well, starting aft, we're in the bunk area, and we can see that there's a frame very close together the whole way, all the way forward. Let's go take a closer look at the one we were working on yesterday. So it's this one right here. So they still need a bit of work. They need to be reduced to their correct height so that they line up with the bulkheads. But you can just feel the strength of these, you know, being this close together and coming right around in a circle. Like I was describing with the Japanese fishing balls, they transmit any energy or any impact right around. So it's a very strong but light structure. And then pan back aft one more time. We've got some nice arc going on the two that are in the main area. Well, there's a lot more to do, but I feel as though we've hit a major milestone getting all the frames in. Well, Rovers, I am really happy with the progress that we made in this video. So now all the bulkheads and all the ring frames are installed. This feels like a milestone to me because, in a way, psychologically anyway, I feel as though I'm on track to make our launch this summer. Now, speaking of that, in the next video, I want to do my most controversial video to date. And I had said that a little while back, and I just wasn't ready to make it. I needed some more footage. So it's a video that will be all about the sail design that I'll be using on Wave Rover. Now, there'll be a second half of that video where I want to talk about an opportunity for someone to participate in what I've been calling the Joshua Challenge, and that is sailing from North America to the Azores this summer with me. Now, there's a couple of other boats that are going to be involved, and the thing is, you know, it has to be sort of a classic, no engine, your own wind vane, that sort of thing, a small boat. And there is a boat that is going to absolutely fit that perfectly, and it's going to be available. I'll tell you more about that in next week's video. Until then, thanks for watching. I'd like to take a moment to honor the Wave Rover benefactors. So what is a benefactor? Well, these folks have made a contribution of $100 US or more to the project, and their names will be affixed to a bulkhead inside Wave Rover and will be traveling with me on our circumnavigation. Now, these donations truly are much appreciated. Well, the Wave Rover patrons, with their pledges of support, really do make the creation of these videos possible. Now, if you'd like to know more about Wave Rover's patron page and benefactors bulkhead, I have links to both those pages in the video description. Now, another way to help Wave Rover, and it doesn't cost you a dime, is by sharing our content on your social media. So now, as always, Rovers, thanks for watching. Give us one more. Brilliant.